Good morning, good morning, good morning. Okay, today is January 21st, and in class, students are going to be working on the STAR test. Those that are at home, you're going to be working on this. So, let's take a look. We are going to look at inequality systems today. Now, inequality systems are probably easiest just to use Desmos, but you can also use elimination and substitution method. But we're just primarily going to look at it using Desmos. So, first I want you to recall, how do we graph a system of equations? So here we have two of them, okay? Now, we could easily plug this into Desmos, but I made these equations pretty simple so that we could graph them ourselves. So the first equation starts at positive 2, and then their slope is 2 as well, so it goes positive 2 and up to right 1. Okay, now, we can only get 2 dots there, and we definitely want to fill out as many as we can, so we're also going to go down 2 and left 1, which is the opposite of that, right? And we continue. So this is our first line. We draw some arrows because it does extend on forever. Okay, and then our second line here, we have starts at -1, and then it goes down, goes up 1 over 2. So it starts at -1, goes up 1 over 2, up 1 over 2, okay? Now you can see it's going to cross over at some point on the left side, so let's go the opposite way. So instead of going up 1, right 2, right, we're going to go down 1, left 2, which brings us to right there, and down 1, left 2 brings us over here as well. Okay, so here's our second line. Put some arrows on it. Okay, it definitely touches those, all right. So where is our solution? Well, the solution to this system is right here, which is -2, -2. Okay, so when looking at a graph of a system of equations, the solution is a coordinate point. Just a singular coordinate point, or it could be, infinite solutions, or it could be no solutions. But in this case, the example I gave you, it is just a coordinate point. All right, so here's the difference, okay? You have a system of inequalities. So notice now that we're back to using this greater than, less than, all those symbols. So recall, okay, down here I'm going to put some important information. Which type of inequalities are dotted lines and which are solid lines? Dotted lines are your greater than or less than symbols. Your solid lines are where you put the line underneath of it. Okay, so that's important to know. So if we go back up to this example, we can use Desmos to graph it, but I'm just going to graph it by hand. We start at 2, go up 2 over 1. Same that we just did. Go down 2, left 1, down 2, left 1, down 2, left 1, etc. Okay? But notice that this is an inequality symbol and it's a less than. So that means, since there's no line underneath of it, we need to put on here a dotted line. Okay? So there's our dotted line. All right, and now the next one is actually got a line underneath of it, so it'll be a solid line, okay? But before we do that, we need to shade. So anytime you have an inequality, remember you have to shade it. So this is less than, which means that it is shading on the bottom side. So as quickly as I can here. Okay. Now what I'm going to do is I'm going to type the next one when we get to it into Desmos. Well, actually, we can just type this one in. So let's go ahead and type this one in, and you should see that it should look the same. Put it in projector mode. It is. Okay. So my first equation was y is less than 2x plus 2. And if you look on the right-hand side here, you can see, okay, that it is in fact dotted and it's on the bottom side. Okay, so let's type in our second one. What should our second one look like? Y is greater than or equal to 1 divided by 2 x minus 1. Oh, so it's a solid line and it's shaded above, right? Okay, so we go down to where it is. We can use green, that's fine, to -1. Go up 1 over 2, just like the other graph. Okay, and this one's a solid line. All right, And again, don't forget your arrows because it goes on forever. And it is shaded above because it's greater than. So a solution to this system, right, is no longer going to be an ordered pair. And the reason for that is because, is no longer going to be where they intersect. And the reason for that is because one of these lines is dotted. So at this mark, yes, they touch, but because this is dotted, that means that it cannot be a solution because it's on the dotted line. So a solution to this system of equations is where the two colors overlap, right, which is right in here. So a sample solution, for instance, would be up here, which is what? 3, 4. That's a sample solution or a correct solution. When looking at the graph of an inequality, the solution set is in the double shaded area. Or region. Okay, so your solution set to a system of inequalities is always in your double shaded region. All right, so we're going to do the same thing here. Let's graph on Desmos. This is a pretty complicated equation, it looks like, and this one's a little bit tough too. So let's graph it on Desmos, and then we'll sketch it below. Negative 5y is less than negative 2x plus 25. Okay, so this one goes all the way down here to 0, negative 5. And then, let's see, goes up to 5, negative 3. 5, negative 3, and that's just me tracing it along. All right, and that's pretty good right now. We're just going to use 2 lines. Okay, and that is a dotted line because, again, it's a less than symbol. Dotted line. Okay. And even though it's a less than symbol, we had to divide by a negative, right? So when you divide by a negative, here to get y by itself, so if we had done that, negative 5y is less than negative 2x plus 25. So if I want to get y by itself to graph it by hand, I'd have to divide by a negative 5. Which, when you divide by a negative, as you recall, we talked about this, it flips the sign. So that would have changed it to a greater than, which is why on Desmos to the right, it's shaded above. Okay, that's why. Because this was a negative out in front of y, so when you divide by a negative, it flips the sign. Okay, so let's go ahead and shade that region here. What I should do is make this a little bit thicker of a shading utensil so that I'm not spending 25 minutes shading here. Okay, second equation, x is greater than negative 2. Well, we should know that because we look at the x-axis, go to where x is negative 2, which is right here. Okay, and it's a solid line because it's got a line underneath. So this line should be like this. Okay, and it says the greater than, and we don't have to divide by any negative, so that means that it's on this side. Okay, and then let's check that on Desmos just to verify. X is greater than or equal to negative 2. Voila. Okay, so where's our double shaded region? It's up here. Okay, so any solution set or any point that's up in this area is a solution. All right, so sometimes you need to solve for y. When doing this, you can multiply or divide both sides. If you multiply or divide both sides by a negative, okay, then flip the directional inequality symbol. Okay, so if you multiply or divide by a negative and you're trying to just graph it by hand, you have to flip the symbol, which means you're going to shade on the opposite side. Okay, so there are some special cases of linear equations. What does x less than 4 look like? Well, it's a vertical line right? And it's dotted, vertical dotted line. And since it's less than, shaded left. So how about x is greater than 4? Well, that would be a dotted line shaded right. Okay, so depending upon what it is. So what do you think y is less than 4 and y is greater than 4 look like? Well, those, of course, would be horizontal lines, dotted because there's no line underneath the inequality. And if it's less than, then that's going to be below. Whereas if it's greater than, that's going to be above. Okay, so something to consider is those special cases where you're not necessarily doing a slope, but remember they're just horizontal and vertical lines because it's the same as saying like x equals or y equals. All right, so let's look at 3 more examples here. Now, can you go backwards? Write the system of equations, create it with this graph, and then check your answer with Desmos. So let's look at this blue line. Okay, it starts at a positive 5, so if we write it in slope-intercept form, we know it's y is equal to plus 5, right? Also, there's a shading, so that means that it's got to be an inequality, okay, because it is shaded, and it's shaded below, which means it's less than. Okay, and then what's our slope? Well, it goes down 1 over 1, down 1 over 1, down 1 over 1. So our slope would be negative 1 over 1 x. Okay, so that's our first one. Or we don't really need to write negative 1 over 1. We can just write negative x. Okay, so let's type that in, see if it looks similar to what we've got here. So y is less than or equal to negative x plus 5. Yep, looks pretty good, right? They're both shaded below. And it looks like it goes through 0, 5 and touches at 5, 0. So down here and here. Perfect. Okay, let's try the second one. So the red one here. Let's see, it crosses the y-axis at 1, 2, 1, 2, 3. That's where it touches. And it looks like it goes down 1 over 3. Down 1 over 3. So my slope here is negative 1/3 x. Starts at a positive 3, and it's also shaded below, and it's also a solid line. Okay, so you have negative 1/3 x plus 3, and now you have your 2 lines. And as you can see, our graph looks very, very similar. Okay, if we go like this, you can really see it. Right, it's got this cross, and that intersection here was at 3, 2, and so this one is also at 3, 2. All right, so let's look at number 7. Determine if the following coordinates are solutions. So let's just graph these. Y is less than or equal to 3x minus 5, and y is greater than or equal to x plus 2. Okay, so is 6, 10 a solution? Well, where is 6, 10? We don't need to label it. It's up here, and that is in the double shaded region, so yes. How about 1, 4? One 4 is in a shaded region, but it's not in the double shaded region, so this is a no. And then 8, 15. 8, 15 up here in the black. Okay, and that is as well. Okay, so that's how you check to determine if they're if their answer or not is where are they located in the system. So check each point, right? Yes, no, yes. Okay, last one here. Below is the graph of a system of inequalities. First, write the 2 inequalities of the system, and then list 2 possible solutions and 2 non-solutions to the system. So let's do this blue line here first. Blue line, you have a y-intercept of 4, and it looks like it goes down 1, 2, 3 over 1. Okay, so we have y, and it's shaded below and it's a full line, so negative 3 over 1x plus 4, okay, which we can check to see if that looks correct. Right, sure does. Yep, shaded on the same side, intercept of 4, also crosses a little bit after 1, I agree. Okay, so let's look now at the red dotted line. It's shaded above, so we know this is going to be above. It crosses the x-axis at negative 2, and it goes up 1 over 2. So this would be 1/2 x, should be. And let me change the colors here so that they look the same. There we go. Does that look the same? Sure does. Perfect. Okay, so where are two solutions to this graph? All right, well, the solutions are in the double shaded region, which is over here. So you can pick any two numbers. So I'm going to pick right here, which is negative 5, comma 1, and I don't know, somewhere up here, which is negative 3, comma 7. Okay, so there's two solutions for me, negative 5, comma 1, and negative 3, comma 7. All right, and where would two non-solutions be? Well, 5, comma 5 would be a non-solution because it's not in a double shaded region, and 5, negative 5 would not be a solution. Okay, so that's how you identify where the solutions are. So that's it. I told you guys it would be pretty simple. You're just graphing inequalities. Don't forget your shading. It's similar to what we've already done. So you have an exit ticket, same idea, 3 questions.